Hello there. Welcome to the free response problem of the day. I hope you're doing good today. And today we're going to look at the 2006 number 2. We got our linear regression situation going on here. So let's see if we can figure this one out. I did modify this one a little bit because it contains something that's not going to be in this year's exam. But anyway, let's read the problem and see if we can figure it out. So this one says a manufacturer of dish detergent believes the height of soap suds in the dishpan depends on the amount of detergent used. A study of the suds heights for a new dish detergent was conducted. 7 pans of water were prepared. All the pans were of the same size and type and contained the same amount of water. The temperature of the water was the same for each pan. An amount of dish detergent was assigned at random to each pan, and that amount of detergent was added to the pan. Then the water in the dishpan was agitated for a set period of time, and the height of the resulting suds was measured. A plot of the data and the computer output from fitting a least squared regression line to the data are shown below. And so there's the plot of the data with the amount of detergent and the height, and then there is the computer printout. And then here are the questions being asked. Part A, write the equation of the fitted regression line, define any variables used in this equation. Part B says, note that S is equal to 1.99821 in the computer output. Interpret this value in the context of the problem. And then part C is actually a problem that would be in chapter 12, which we didn't do, and the College Board has said is not going to be a part of the 2020 exam. It said, identify, interpret the standard error of the slope. So we don't know about that. So I've changed that to the problem that I think is the most frequent linear regression problem asked. And that is this, to identify, interpret just the slope. Just the slope. To identify, interpret the slope. And so that's what I want you to do. So if you want to pause the video and do those 3 things, that would be great. Okay, great. Now, so let's look at this. Now, first of all, just some things they could ask you. The amount of detergent is what we call the explanatory variable. And then the height is the response variable in this situation. And you have to understand how to read the computer printout. Remember, all right, this coefficient of constant, that's A. So the first number is A, and the one that below it, that's B. So that's the y-intercept, that's the slope. These numbers we will never use. Right? We don't use those in AP Stats at all. And these we would have used in Chapter 12, and I would have enjoyed teaching them to you, but alas, we don't have to worry about these either. So like that. And so then we won't use R squared adjusted. It's these 4 numbers you got to be able to work with. A, B, S, and R squared. R squared, of course, you weren't asked about here. It is the percent of the change in Y that can be explained by the change in X, or can be explained by this model. So if you were asked about that, you would say 96.9% of the change in the height of the soap suds is related to the change in the amount of detergent. And so in other words, the other 3.1% are other variables. So it could be, I don't know what other variables could be going on. But anyway, so let's answer the question that's asked here. Write the equation of the fitted line and define any variable. Of course, even if it didn't say that, you would still define the variables. That's important. So there's A and there's B. And so here is our equation. Y hat, and put a hat on the Y because this thing is predicted Y values, not actual Y values. And there it is. And so X is the explanatory variable, the amount of detergent in grams. And then Y is the height of the suds in millimeters. And so that is the answer to that question. And then part B says, there's S, so interpret this value. S is, of course, that number there. Okay, S is that. And so that is in essence the standard deviation of the residuals, or in essence the average of the residuals, since the in sort of, because the residuals are going to have a mean of 0. But anyway, and so what it is intuitively, it's the average amount our predictions are going to be off. And so what we interpreting in context, we would say predicted Y values or predicted heights of the suds using this model will be off by 1.99821 millimeters on average. So it's the average amount our predictions are going to be off, but you have to say it in context. And so that's how you would answer that problem. And then part C, to identify and interpret the slope, well, that's B. That's this 9.5. And this is how you would do that. Is the slope is for each increase in 1 gram of detergent, we predict It's important that you say we predict or we expect, all right, that the height of the suds will go up by 9.5 millimeters. And so that is interpreting the slope in context. The slope to us is this. The slope is when x goes up by 1, it's what we're predicting is going to happen to y. That's what the slope is. So please be able to say that properly. Now, by the way, and just to satisfy your curiosity possibly, the standard error of the slope, that is this number here. That's that 0.7553. And that is the average. And so, it's the standard error that is the next to the slope. It's the average amount that the slope would vary in repeated sampling. Okay, so and so that's what we would have said there. So the average amount that the slope varies in repeated sampling is 0.7553. So it gives us an idea of how accurate this 9.5 number is. And so that's that. That is our that's our FRQ of the day. If you have any questions about that, please send them to me. And that's it. Have a great day.